theoretical knowledge about big data, but yeah, this would be the first training.
Sure. Neelam? Can you hear me?
Mute. Okay, now you can talk. Neelam, we can't.
Okay, looks like Neelan has issues with the audio. And put it in the chat window. Do you have any programming background? Or do you have any database knowledge or scripting technologies that you have worked on? Anything. Just give a background, little bit about programming experience. If you can, be great. Otherwise, we can get started. Go ahead, type, and in the meantime, I'll get started. Add before we continue.
Actually, just got a message from Neelan. I think so. He's writing privately instead of everyone. He just said that he has 15 years of experience in engineering and design experience, and he worked in on different technologies.
Oh, fine.
So okay. just a quick tip for you. If you want to do a chatting, you might want to send to everyone that way, or at least send to Krish, so that we'll be able to see your chat. That's okay. Please.
Okay. So, Sunny, I'm sure you must have already given the overview of Tekcloud to our resources. So I'm going to skip this particular part for now, given the time availability. So move on to our Spark demo. Okay. So what we want to talk about in this demo here is what actually Spark is all about, and where this Spark comes into the picture, and how Spark is solving the business problems that are related to big data and non-big data solutions as well. So is it that Spark is only related to big data, or is it something that it can solve outside big data problems? So those are things that we'll try to solve. And what is the market stake for Spark, and how people have been adopting, and what are the trends that are there in the Spark community? So those kind of things that we will try to understand, and we do some kind of comparisons, all of that stuff, and that gives you enough information. In order to understand what the Spark is all about. And there you can start building your skill from there, so that it will be easy for all of us to start getting onto Spark technology. Okay, as the name says, it is Apache Spark. So Spark is an open source technology. So Spark is basically a distributed computing platform. It's a distributed computing platform. So those who have some knowledge about what exactly Hadoop and MapReduce, the HDFS, so where this Apache Spark fit in, I'm sure you must have done some research about big data, some research about Hadoop, or you must have already worked on Hadoop technology. To give a overview on where exactly Spark comes into the picture, at a very high level, we all know about Yarn. So Yarn is a resource manager technology. It's yet another resource negotiator. So what Yarn does here is, there is Hadoop component. Hadoop actually solves two problems. One problem here is storage. I'm sure all know about HDFS, Hadoop Distributed File System. So HDFS is a file system that solves your storage issues. I mean, have tons and tons of data. I have petabytes of data, terabytes of data. Earlier, on the current system, I never used to be able to store so much of information. So HDFS solves that problem to me. Okay, now I have stored a lot of data on HDFS. Now I want to process it. I cannot use the conventional technology in order to process that particular data stored on HDFS because the nature of the data is distributed. So it's separate paradigm that enables you to process that volume of data that is stored on HDFS. So we had a technology called MapReduce. I'm sure we must have heard about MapReduce. MapReduce is a mechanism, is a programming paradigm that enables the developer to solve the problems that is stored on HDFS. That means the data that is stored on HDFS is required a different programming paradigm called MapReduce in order to process the data. We cannot write general C++ program or program in order to just access the data that is stored on HDFS and then process it because it is distributed. The data is broken in multiple parts and thrown onto the cluster. Okay, problem the MapReduce was actually solving many problems, and for last 6-7 years, where since Hadoop inception, MapReduce was really a great deal for many organizations to solve their critical, the complex problems that defines the big data, that defines the volume, that defines the variety of data. MapReduce used to solve all of those, but the small hiccup with the MapReduce here is MapReduce is a batch-oriented system. That is, MapReduce is designed to be worked with any conventional hardware. Any conventional hardware. When I say conventional hardware, it is a your laptop, my laptop, and someone's laptop. With 3 laptops, we should be able to build the Hadoop cluster, just like that. Hello. Hello.
Hi.
Hi. Yeah, we get started just now. Samir, right?
Just notified just
okay.
a few moments ago from Jabri.
Okay, we just got started. So if you have any questions, you can hold on those questions at the end of the presentation. We'll be more than happy to help you with that. Yeah.
All right.
Thank you, Samir.
Sure. Okay. So as I said, Hadoop used to solve 2 problems. One is storage, other one is MapReduce. So we understood how we are able to mitigate the storage issues using a technology called HDFS, and we understood that MapReduce is a programming paradigm that the data that is stored on HDFS. This is the fundamental Hadoop technology. So on top of it, so to make the developer life better, there is a concept called Pig, Hive, Woozy. So many things have evolved. They call it as Hadoop ecosystem tools. Okay. So, but the MapReduce is the one that was actually solving major of the problems, all complex problems like machine learning, graph solutions, everything it used to solve. But now the problem with MapReduce here is it is a batch-oriented processing system, and because it's a batch-oriented system, we were unable to solve the problems that are related to real-time, that are related to some kind of streaming, that are related to some kind of instant result scenarios that give the input. Now I should be able to get the output in 1 second or 2 seconds or 10 seconds. Like Oracle. In Oracle, you give the SQL query. Probably if you're processing any meaningful data, you get the response immediately and you can integrate that one with your application. But Hadoop is not like that. I mean, MapReduce was not designed for that. MapReduce was designed for batch processing system. So this was the base for Apache Spark to evolve. So Apache Spark took this as a problem statement, and they created new technology called Apache Spark. So Apache is a computing platform. It's a computing platform designed to be fast and general purpose. So it is very fast compared to MapReduce. How fast we will see it, and a framework for distributed processing. Also, when we talk about anything on big data, so big data is basically processing or the distributed processing with distributed storage. Okay, from the data that is stored on distributed storage is what our entire big data statement. So Spark exactly fits in there as well. Okay, so it is actually a distributed processing system in order to process the data that is stored on distributed machines. Spark additional advantage here is data not necessarily to storage, it can even be on your local machine also. Spark has the ability to process that amount of data. And one of the biggest advantage with the Apache Spark is it is an in-memory engine. When engine map is not a memory engine. It is not an in-memory engine. It is a serialized processing system. That is the reason it is called as batch processing. So it leverages a lot of serialization techniques in order to store data to and fro disks, and disk is always slow compared to RAM. So runs everything in memory engine concept. So that is one of the reasons why Apache Spark has shown tremendous results when compared to MapReduce. And as I said in the beginning, it is an Apache, so it is the Spark is an open source system, and this open source gives path to many developers, many community users to process, to commit, or to submit the code that is relevant to Spark. If you have hunger to code Spark, you can go ahead and be a part of the committer, and then you can write the code as well for the Spark. So that is the advantage that you gain with Apache Spark, and the community base for Apache Spark is the number one in the world today, compared to any other applications that are there in the open source. Advantage with Apache Spark is it is an unified stack. So unified stack, in the sense, I'm sure those who are familiar with Hadoop, they might understand the fact that if you want to do SQL style processing, what do here is you adopt a technology called Hive. Hive behind the scenes convert everything into MapReduce, and MapReduce process the data that is stored on HDFS. Doing some kind of ETL operation, then what do here is you choose the mechanism called Pig, Apache Pig as a technology, and you write some kind of scripts, and then you process the data. If you do the streaming on Hadoop, what you can do here is you do there is a concept called Hadoop streaming. Either you have to adopt Hadoop streaming or Storm or any other technologies in order to do the streaming activity on Hadoop. When it comes to Spark, Spark comes with a unified stack. Everything is bundled in Spark. You want to perform SQL operations, you have a Spark SQL library. You want to do the streaming operations, you have a Spark streaming operations. You want to perform machine learning, you can perform MLlib. You want to perform graph theory, all the graph theory operations. So these all are different independent components bundled with the Spark engine, so that you don't have to go for different technologies for different scenarios. Like you want to perform SQL operations, you don't have to go for Pig or Hive or import any other technology. You can raise Spark SQL here directly. If you want to do the Spark streaming, then you want the streaming, you directly come to Spark, and Spark everything comes with out-of-the-box functionality, which you can directly leverage and start using it. That is one of the biggest advantages that you gain out of it. The Spark streaming in real time. Machine learning. So in we used to have a mechanism called Mahout. I'm sure you must have heard about Mahout. So that is actually a machine learning library for Hadoop to solve some of the predictive models or data science problems. But it is also embedded in Apache Spark. That is advantages. Now, on top of this, the Spark advantage here is it works with any kind of cluster managers. Any kind of cluster managers, in the sense, MapReduce can work only with Yarn. Yarn is one of the cluster managers that manages your cluster. A cluster is, just to say, a cluster is a group of missions that are designated to do one particular task or one particular job. So what is happening here is this MapReduce can work with Yarn, whereas Spark can work with a variety of cluster managers like standalone scheduler or the Mesos or Yarn or local. There is another aspect called local. Okay, so the variety of flexibility that we have when it comes to Spark technology. Spark has the ability to work with any of the cluster managers that is available. And these are the major players in the big data industry, and it works with any of them. Standard inbuilt cluster manager for Spark. Yarn is a open source again, and it is widely adopted in Hadoop technology. And Mesos is one of the latest initiatives that has come from University of Berkeley, and now it's again open source. And Mesos is really supporting many latest cutting edge technology in order to run the jobs on the cluster. So Spark supports Mesos. Some of the advantages that you gain out of Spark. The primary objective of Spark here is it's a fast and general purpose engine for large scale data processing. When we say large scale, it's for any size of the data you should be able to use it. And actually, if you look at it, traditional all libraries, traditional libraries have been written in all in Java or in C++ or anything or C. Whereas Spark is completely written in a technology called Scala. Scala is again an open source language. It's a Scala language actually. So it's a functional programming language that does both your object-oriented programming and your structured programming, along with the functional aspect of the programming paradigm. So, Scala is one of the primary technologies that people use in order to code Spark libraries. Okay, and it comes with interactive shells like Spark Shell, PySpark, all of those. So you can the Spark library is now available for Python, Scala, Java, and R technology. R is for data science. Interactive shells we have for R, Python, and Scala. The three for Java there is no interactive shell, but for these three technologies we have interactive shell. I mean, interactive shell, I'm sure you guys know what I mean. Those who want to work with Python, if you type Python, you get the prompt, right? So interactively you can write the statement and you can evaluate then and there whether the statement that you have done is correct or wrong, and then you should be able to process it. Okay, so that is one of the advantages that you should be able to see with Spark. And the next one here is these technologies that we have been using it, and this is mainly for large scale data processing. So as I said, the way how Spark evolved here is after Apache Hadoop. After Hadoop became popular, people understood the fact that there is a lot of gap in MapReduce, and that is where paper has been presented, and Mr. Matai from Berkeley University, he presented, and from there it started. From there started the journey of Apache Spark. Now almost every organization is trying to migrate from MapReduce to Spark, and most of the companies have been taking Spark as a de facto technology for all their processing needs. It is not just for distributed systems, even for local processing needs as well. Even for local processing needs as well, people have been using Spark as a mechanism to process their data. So advantages with Spark can work with any kind of any kind of, it could EC2, that is AWS. It can work with Hadoop. It can work with Mesos. It can work with in your laptop, in my laptop, or in virtual machines. It's a set of libraries. You can download the library and you can start using it, and it'll give you a lot of advantages of processing the data in a seamless fashion. And it can, one of the biggest advantages with Spark here is Hadoop cannot go to any data source unless otherwise you write something explicitly with the file formats, and explicitly when you say that, okay, please go ahead and reach out to Oracle and then get the data. For that, you have to do is you have to write a JDBC program in order to connect to the database. As here, you don't have to write any JDBC programs or anything in order to reach out to variety of data sources. You can reach out to any relation. You want to work with flat files, CSV files, TSV files, pipe delimited files, you name the files, type of the file, you should be able to work it. And it can work with the distributed file systems like HDFS as well. And so-called NoSQL databases. Today, the ruling databases are NoSQL databases. So it can even directly interact, the Spark can directly interact with NoSQL databases like HBase and Cassandra in order to process the data, This is the people why mainly go to Spark here is Spark has a lot of flexibility compared to your MapReduce programming paradigm. MapReduce is one of the proven technology in last 6-7 years to process data in a distributed fashion. Now, Spark has given much more flexibility than MapReduce in order to process the data. So MapReduce is primarily to go to HDFS and process the data. Whereas Spark, HDFS is one aspect. There are many aspects in order to process data. Also, as I said, unified processing, unified stack. It has already all default packages. That is, out-of-the-box packages are available already in Spark in order to process the data. And there are some of the comparisons that you can do with MapReduce. So if you want to write MapReduce code, it takes so much of time. And if you want to if you write it in Spark, you will see less. So it is 100 times faster than what I've been seeing here. It is 100 times faster than what you have been seeing here. So if you want to write MapReduce programs, this is the standard. If you write a Spark program, it is the program. You should be able to work out with a decent code base. Okay, this is one of the advantages that you gain out of it. And these are some of the comparisons between Hadoop and Spark. So what the Hadoop and Spark? Why we are completely comparing the Hadoop and Spark here is because of the fact that Hadoop de facto standard, whereas Spark is the latest one. You see here, in order to process the data of size 102 terabyte of data, it took only 72 minutes, whereas Spark took only 23 minutes. But I say 100x performance, why it is only showing 3x, but the point here is Hadoop took the nodes of 50,000 cores, whereas Spark took only 206 nodes with 6,500 cores. If you look at it here, 6,500 versus 50,000, it is almost 10 times. It is 10 times lesser the hardware capacity, and it produced 3 times better Hadoop throughput. So that means it is almost close to 30 times faster than Hadoop in a complex scenarios like sorting. Whereas when you do the regular processing, it is 100 times faster than your Hadoop technology. So your Hadoop MapReduce technology. So these are some of the comparisons why people really go for MapReduce, and why really people love to work with Spark because of this particular reason. Hadoop is a batch processing system. So give the input now. You cannot expect the result immediately. There is a definitive delay will be there here. The definitive delay will be here is processing and post-processing. This is the only processing time. Processing time may be 10 seconds, where pre-processing and post-processing might take 10 and here. It could be. It's not acceptable in order to process 10 rows. Even 10,000 rows, still this is going to be the processing capability. It needs much of processing, pre-processing and post-processing. This is what the nature of batch processing. This is batch processing. But interactive is you get input you can expect response in with a definitive time, like SQL Server, or you write a Java program. You should be expect the result in a definitive time period. That is one of the advantages that you get with the real-time streaming. Okay, that is something that you should get it with Spark as a technology. As of today, you can code MapReduce. This is a very high level technology. Java is one of the technologies that is supported. Of course, it has some other libraries like C++ and all, but only Java is the one that is that's been exclusively has been added here in order to program MapReduce. Whereas Spark comes with many technologies like Scala, Java, R, and Python, and now people are trying to add few more technologies for like scripting technologies, so that people should be able to process the data. Okay, these are some of the things that's been happening. These are some of the things that's been happening in terms of MapReduce and Spark has shown tremendous results in terms of processing, and almost every company started adopting Spark as a technology, and not everybody can learn Spark. Spark comes with some cost, in the sense unlike any scripting technologies, unlike a tool, you just go and drag and drop and then get the things done. It is not really like that. So in order to write a Spark program, one has to have the programming background, and one has to have some understanding on how libraries work and what exactly the distributed system is all about, those kind of things. So one has to have either Python or as a programming background in order to process the data, using Spark. So these are some of the basic things that we wanted to talk about as part of our Spark demo. And we can get in some kind of comparisons. See, if you look at it, there is those who are familiar with the data science, those who do kind of algorithm implementation. K clustering is a very popular IT algorithm in machine learning. So what there's like a scoring models kind of as a training. You train the data set one time, and next time you train on top of it with the data. Again train the data, train the data like this, in order to come to a conclusion until you see the desired result. It's like iterative models. If you write a k-means clustering on Hadoop, it takes 121 seconds, whereas in Spark it just takes 4.1 seconds in order to process it. Now you can imagine how much time it took in order to produce the results. And the thing is logistic regression. We all must have studied in academics, like in stats, the regression models. So logistic regression is one of the algorithms that is used very extensively when you are writing your iterative algorithms. So there you must have you could see that if in Hadoop MapReduce it takes 80 seconds to process it, whereas in Spark it is not even, it's less than a second. So those, it's already proven, and many companies have started already adopting. It is not just for data science, even for ETL processing. Okay, you have lots and lots of data transformations to be completing. Then you can use Spark as a mechanism in order to do it. It is for both data engineering and data science. Okay, these are both. Two of them are users for this particular technology. Okay, some of the things that I wanted to talk about, and here the benefits of Spark here is, earlier it used to be people say impractical analytics, like there is a genome sequencing, one of the use cases. The weather forecasting is one of the cases. Here people if people wanted some kind of real-time updates on the weather forecasting, what's going to happen in the next 1 minute or 2 minutes, it used to be very difficult. Now it is not, because now it is a very easy processing. With entire USPS processing is happening, the distribution happening through Spark engine. And very low cost. It is First of all, it is open source. Anybody can download. Anybody can start leveraging it. It's very less time. Obviously you're going to save a lot of time, and it is a greater flexibility in terms of technology. If you know Python, if you know Java or Scala or R, you can go ahead and start leveraging Spark, and it's a near linear scalability. Near linear scalability in the sense it's almost as good as your real time, and you can scalability is in terms of expansion. You don't really have to worry about the size of the RAM or anything. You can add anytime, and your system will be able to pick it up. Some of the things that you should be able to find some sort of benefits out of Spark. Questions so far?
Since I was only notified about this recently, and I came in late, how much did I miss, and will you is it able that you can email me the so I could go over them by any chance?
Yeah, sure.
This is Sunny here. So what I would be doing is I would be sending you the link to the YouTube or video for this particular presentation, and you'll be getting an opportunity to go through it. Okay.
All right.
No problem.
Okay. Any questions?
Thank you.
Okay. Perfect. So here is the course content that we will be discussing as part of our Spark. So we'll be talking about the complete introduction to Spark and what exactly it is all about and what are the libraries, all of this, and then we talk about RDD basics. RDD is unlike in every programming language we have data types, right? Similarly, Spark library defines such certain data types. So what exactly the data type is all about and what exactly the RDD is all about, those kind of things that we will be talking exclusively from the Spark's perspective, and how to create RDDs, how to manipulate RDDs, what type of RDDs that we have, all of those that we will be able to discuss in this particular section. And then once we discuss RDDs, so we are moving away from MapReduce, but still MapReduce has certain advantages in terms of processing the data in two different phases, like map phase, reduce phase, blah blah blah. So I can leverage that MapReduce paradigm within Spark. So that is the concept called key value pairs. We will try to understand what exactly this key value pairs are all about and how you solve the problems using these key value pairs, those kind of use cases, and some kind of API, Spark API. We'll try to understand, and we'll do a lot of programs and a lot of practicals around key value pairs. We'll try to perform here. Once this is completed, then load and saving data is one of the very prominent scenarios that need to be discussed in Spark. That how I can go to different sources and load the data. Example is I want to load a flat file. I want to load the data from the databases, or I want to load the data from some XML, or I want to load the JSON data, different of data. Okay, variety of data. How I should be able to do it, and how I can handle databases. What is the JDBC mechanism? Those kind of things that we will try to understand in this particular section. And the very prominent one here is the Spark SQL. The Spark SQL is, see, people are still in the mode of running programs in the SQL mode. Okay, Spark also comes with SQL capabilities. So how Spark can enable the developers to write the SQL code, and what exactly you should be knowing, what is the data frame, how the data frames are converted to the SQL transformations, those kind of things that we will try to learn in the Spark SQL, and we do some kind of POCs as well on Spark SQL. Okay, so that is another thing. And in the beginning, we understood that Spark can run on many type of clusters. It could be standalone mesos, it could be Yarn, or it could be your local, all of those. So we'll to learn how it is possible and what exactly the Spark running Spark code on different clusters, how it is possible, those kind of that we will try to understand. We will look into some kind of configurations, how it really enables you to perform such things, and we will try to run the code using local, using standalone, and using yarn cluster managers. So in this section, we do a lot of practicals in terms of Spark deployment. And the next one here is the Spark streaming. So Spark streaming is one of the most happening technologies in the current big data space. Not just Spark streaming, any streaming data. So in the data real time, and you ingest the data real time, and you do some kind of analytics on top of it. That is Spark streaming. That is Spark streaming. So how you can do the Spark streaming, and what can, like, we do example of Twitter. So we go to Twitter, and then we'll try to capture all the tweets that's been happening on a second by second basis. Second, what tweets have come, how it has come, who have tweeted what, those kind of things we should be able to real time. We can go and find out the tweets. Those kind of things that we should be able to do it. And on top of it, what we do is there is a Kafka integration, there is a Flume integration, different kind of technologies integration. At a theoretical level, we will try to see how we can integrate with the Kafka, how we can integrate with the Flume, all of that stuff that we'll try to learn very extensively in the Spark streaming aspect. Okay, this is very, very, very important and very interesting topic in big data space. Okay, so that is something that we will try to learn in this subject, and we will do one whole use case. We will take one pipeline, and then we will try to do it. In learn Spark, first thing we are going to learn two technologies. One is Python, and other one is Scala. As part of this training, we train you on both Spark as well as on Scala. That is needed to code or to program Apache Spark. Okay, not going to be end-to-end Python or end-to-end Scala. To an extent, the language features that is needed for a developer in order to write a Spark program. Okay, so take all of those things into the consideration, and then we'll try to get into the Spark development. Okay, some of the program features that we will be covering, and on top of it, we will be covering some latest technologies like Jupyter, how to practice, what are the notebooks that are available in the market for Spark, all those things that we will try to learn in this particular technology. Okay. Any questions?
So how training?
Training spans for 4 to 5 weeks, and every week is going to be 3 to 4 classes. It depends on the length of the class. So most likely all the time it's going to be 1 hour 15 minutes each class. If we get onto the weekend class, it will be almost more than 2 hours, close to 2 hours.
Regarding the weekends, is that where we're going to do assignments, or is it going to be classes and assignments separate, or how does it work?
See, there's no separate thing. Assignments will be given to you, so you guys will practice and come during your leisure period. So I'm going to make you sit and do it in the class, because I don't want to waste your time and others' time and my time. So I'm sure you guys anyway definitely be doing it at your own pace. Yes.
So to answer your question, yes, there would be assignments delegated to you guys, and the idea would be that you would do them as the classes progress. And if you need any help from Krish, he'll be more than happy to help you with assignments. By the end of the class, you would be required to hand over your assignments. But you'll be getting assignments from time to time to work on it while the classes are going on. The expectation is that you'll be doing it during your off time and coming back queries. So no questions basically means that you are having you don't have any trouble and you're doing good. So the also responsibility would lie on you.
The daily 1.5 hour class or
It will be 4 classes a week, and each class will be 1 hour 15 minutes. If a class moves to weekend, we will combine 2 classes and we will go at a stretch 2 hours on weekend, one class. We will work with you to see what is the best schedule for all of us, and then we'll decide accordingly.
Yes, sure. The whole idea behind this thing is to work with your schedule. So you a kind of overview of how the things work. So if the students or candidates are comfortable with like 2 classes or 3 classes on a weekday and 1 class over the weekend, that's absolutely fine. So here that the weekend class would probably be for 2 hours, while the other classes might be a little shorter. But it'll be tailored according to your requirements. So I think etched in stone.
okay.
The idea behind this thing is, of course, if you have any questions, queries, you've received email from Tekcloud. Shoot an email back, and what somebody from our training follow-up team would also be getting in touch with you to let you know when the actual batch would be starting, and you would be able to enroll, and other financial questions that you might have. But in case you have any questions that you want to talk about, please feel free to get in touch with me. I'm just putting down my number over here. Feel free to give me a call. I'll be more than happy to help you. I'm just making sure I'm sending it to everyone. So give me a call, and I'll be able to work around any other questions that you might be having. But if you want to shoot an email, that also works for us. We'll be starting after the long weekend. We are on schedule to start the class. Of course, our class sizes tend to be small. We single digits. So each one of you can get the personal attention that you all deserve. And the reason I would strongly recommend that you enroll early as possible. And of course, queries regarding it, please shoot me an email. Any questions?
Billy, are you going to talk about the Java API?
Not to an extent. See, we are not going to practice in Java. The reason here is Spark is primarily, I mean, in the industry is using Scala and Python as the standard technologies in order to code in Spark. Okay, that's one of the reasons where we are doing it. But yes, of course, we can. If you are interested, I'll give you some kind of a demos. But my training material or anything is not in orientation of Java.
So
you
should
said you would send the. Oh, sorry.
Yeah, Sheila.
Should we have some knowledge of Scala before to join class?
As I said, we will be taking care of that one. We will train you on Scala. We will train you on Python before even we get onto Spark.
Okay.
This training, but it's not that the day one we are going to start the Spark and then we'll left it to everything, rest of the stuff. But make sure that we will give all the prerequisites that is needed to code Spark and then get started with the Spark.
Am I asked a question now?
Sure, please, Sunny.
Okay. So you said you were going to send a link to the video
Yeah.
presentation.
Yes, that's Sunny. Yes, you would be sending. Yeah, I would be sending over to whosoever is there on the call today. We get a link to the presentation, and you'll be able to see the recording all over.
For personally, I know Java from school. It's just since I reviewed. Is it possible to get something more specialized myself regarding Java? I mean, I know a little bit of Python already too.
absolutely, absolutely. We can work one-on-one, and whatever the help that is needed, definitely you can reach out to me, and I'm happy to give you all the details that are needed for you to do Spark coding.
All right, thank you.
Sure.
Okay, about the project.
Yeah, here there are a couple things, Srilata. One here is you may want to choose a Spark SQL implementation, or okay, you can do the Spark streaming implementation, or you can do plain Spark ETL implementation, the ETL pipelines. So in the sense, we will give you some example here is, let me share my screen. I'm not sure if you're aware of this data sets. What we will do here is we will go to this data sets, New York open data sets. Okay, this is an open data set. This is a New York city data sets. There are sets available in the internet. We will take one of the data sets and we will try to I'm going to give you an example. This is a simple example. If you look at it, yeah, so data actually, that the subject ID, borrow here is some location and the internet. So the Wi-Fi hotspots will be there, right? Like if you go to Starbucks, internet is free there, Wi-Fi. So whether it is free Wi-Fi or it is a paid one or it is a limited free, those kind of things you have for this information for entire New York. Okay, if I download this one in the New York form, if you open or if I open it in Excel, you might be able to see. If you see, let me open in Excel so that it might give you more. And just so that it will be easy for you. So who is actually giving this free Wi-Fi? So he is it's a Brooklyn Public Library. So it's like a Basil Park, blah blah blah, and the location and longitude and latitude, and X coordinates, Y coordinates, location, some whatever. We read the documentation what exactly this location is and the remarks. Okay, and what is the city and what is the SSID? SSID is you read when you are connecting to Wi-Fi. It'll ask you to select the Wi-Fi SSID. So that is the SSID, the source ID, and the location. Okay? So this information has been given to us for free of cost. The entire New York details are available here. Now I ask you to do some pipelines on top of it, saying that okay, I wanted you to extract by region. I wanted to know how many Wi-Fi hotspots are there for a given area. Okay, we will bring some use cases on top of it, and we'll create the pipeline. Now is in a text file. So what we will here is we will put it in MySQL. So we have MySQL operations here. Okay, so able to go to the MySQL and get data. From my assume this is there, and you are going to load it into the Spark, and then in the Spark you are going to do the computations, and then you are going to load it onto the database back. So these pipelines that you will be performing. One of the examples. I'm going to give you another one. So I'm not sure if my environment is set up. I can show you something here. So we have a Twitter account. So one of the prominent thing that people do here is go to Twitter and capture all the messages. Okay, all the messages. What is happening in Twitter, you should be able to go and capture it. Spark makes that job very easy for you. What can you do with the Twitter data? Your tweets. You say what product is trending and what is who is popular in today's Twitter Twitter content. Those kind of things that you should be able to happily perform that in your I can show you. I'm not sure if I can to tweets. I start seeing the Twitter data. People are tweeting. Now tweets. What after getting the tweets? What should I do? And you being a developer or you being a EL engineer. So what are you going to do with this? So you will be putting this one in a table, and then you are refining the data, and then you give some nice rosy reporting on top of it. All of that stuff that you should be able to do it. Something that you should be able to build it. Since you are familiar with Java, I'm sure you're familiar with the JMS queues. JMS queues. See, this is Spark streaming. We are doing the Spark streaming. Instead of Twitter, you can connect your JMS queues. Bring the data onto the streaming, and then start processing it. Build some machines in JMS. Bring. These all are real-time use cases which we do on a day-to-day basis in our organization. They will be doing, and we will be picking up some kind of projects from here. And if you all at one shot, you can do it after the training. It depends what I'm. You know what I'm getting?
Yes, yes.
Okay.
Okay, everyone. Just want to thank you for taking time off on a Thursday night to come over. And again, if you have any questions, queries, feel free to get in touch with us. And my number is right over here. And what we're doing on our part is somebody from our training team would be getting in touch with you in order to know the best steps forward and get you started with this Spark training program. Okay? So
Thank you.
Thank everyone. Thanks for joining.
Thank you all.